Ratios and proportions. A ratio is a comparison of two quantities by division. You're comparing two things: dogs to cats, apples to oranges, girls to boys, basketball players to football players. You have to understand there's a difference between a ratio and a fraction. A ratio is a comparison of two quantities, and a fraction is part out of whole. So in one rectangle here, the ratio of shaded squares to unshaded squares is 7 to 5. In the other rectangle, the ratio is 28 to 20. Both rectangles have equivalent shaded areas. Ratios that make the same comparison are equivalent ratios. So 7 to 5 is the same thing as 28 to 20. Notice how the portion of shaded area is the same. One has bigger boxes than the other. That's the only difference, but they are equivalent ratios. If we were talking about a fraction, the left rectangle would be 7 out of, correct, 12. That would be your fraction. But since we're comparing two quantities, it's 7 to 5. It's called a ratio. So, ratios can be written in several ways. 7 to 5, 7 to 5, and 7 to 5. They all name the same ratio. Notice how I said 7 to 5 all 3 times. Does not matter which way you write it, you still say 7 to 5, with the 2 in the middle. 7 to 5, 7:5, and 7 over 5, 7 to 5. So here's your examples. If you needed to find an equivalent ratio, on A we start with 9 to 27. There's 2 ways that you can find an equivalent ratio. You can multiply or divide. When you do this, you have to do it to the numerator and denominator, and you multiply or divide by the same non-zero number, meaning 1, 2, 3, 4, 5, so on and so forth, just can't be 0. So the top one, I'm going to try multiplying. I picked 2. So if I took 9 to 27 and I doubled the 2 things that I was comparing, that would give me an equivalent ratio of 18 to 54. If I took 9 to 27 and I tried dividing by 9, I would give an equivalent ratio of 1 to 3. The reason why this works is because you're multiplying or dividing the numerator and denominator by the same number. Here's your next example. If we have 64 to 24 and I multiply by 2 to get an equivalent ratio, it would be 128 to 48 because I multiplied by the same number to the numerator and denominator. Another way is to divide. Let's say I divided my ratio by 8. I divide 64 by 8 and 24 by 8, and I would get an equivalent ratio of 8 to 3. 2 ratios equivalent to 927 are 18 to 54 and 1 to 3. All 3 of those ratios are equivalent. If we were to draw them and say that they were shaded to unshaded, like in the previous example, they would all be the same shaded amount. 2 ratios that are equivalent to 64 to 24 are 128 to 48 and 8 to 3. All 3 of these are equivalent. So, let's check it out. Find 2 ratios that are equivalent to each given ratio. Your first example is 8 to 16. You can multiply or divide the numerator and denominator by the same non-zero number. So if you hit pause now, you can go ahead and try this with multiplication first. I chose 2. So I multiply the numerator and denominator by 2. If you picked a different number, it does not mean you're wrong. As long as you picked a number that isn't 0, and you multiplied the numerator and the denominator by the same number, then you still would have your equivalent ratio. I got 16 to 32. So now take 8 to 16, try dividing the numerator and denominator. Press pause to give you a chance to practice this. I chose division by 4. When I divided my ratio, numerator and denominator, by 4, I got 2 to 4. Here's your next example. 32 to 16. I chose multiplication by 2. If you multiply or divide the numerator and denominator by the same number, can't be 0, you can get your equivalent ratio, an equivalent ratio. Mine is 64 to 32. 32 to 16, try division. Pick a number to divide by. Divide the numerator and denominator. I chose division by 8. I divided my numerator and denominator by 8, and I got an equivalent ratio of 4 to 2. Two ratios equivalent to 8 to 16 in example A are 16 to 32 and 2 to 4. You could have gotten different ratios that were equivalent to 8 to 16. Two ratios equivalent to 32 to 16 are 64 to 32 and 4 to 2. And just like 8 to 16, there are many ratios that are equivalent to 32 to 16, depending on which number you decided to multiply or divide by. So, an additional example, determining whether two ratios are in proportion. So now you are given two ratios, and you have to decide if they are proportional, if they are equivalent ratios. So, 3 to 27, I take and simplify. You simplify both fractions, ratios. If both ratios have the same simplified numerator and denominator, then they are proportional. 3 to 27, I get 1 to 9. Now let's try 2 to 18. You think of the greatest number that goes into the numerator and denominator, it's 2. And I get 1 to 9. So those are proportional. 1 to 9 equals 1 to 9. So that means 3 to 27 and 2 to 18 are equivalent or proportional ratios. 12 to 15. You need to think of the biggest number that goes into both the numerator and denominator, which is 3. When you divide that, you get 4 to 5. Let's see if when we simplify 27 to 36, we also get 4 to 5. The highest number that goes into this numerator and denominator is 9. And I get 3 to 4. That means since they are not equal, the ratios are not proportional. They are not in proportion to one another. So, here's another example. Simplify to tell whether the ratios form a proportion. This is where you are going to practice. 3 to 15 and 9 to 45. Go ahead and pause the video and try to find out if these two ratios are proportional. 3 to 15, the greatest common factor is 3. And when I reduce, I get 1 to 5. 9 to 45, the greatest common factor is 9. And when I divide that, I get 1 to 5. So on A, they are proportional ratios because they have equivalent simplified ratios. The first one, the greatest common factor was 3. When I divided by 3, I got 1 to 5. The second one, greatest common factor was 9. When I divided, I got 1 to 5. They're proportional. Here's your second example. Pause the video and see if you can decide if these are proportional ratios. 14 to 49, the greatest common factor is 7. When I divide, I get 2 to 7. Let's simplify 16 to 36. Greatest common factor is 4, and I get 4/9. Since they do not equal, the ratios are not in proportion to one another. So, let's apply this to science. At 4 degrees Celsius, 4 cubic feet of silver has the same mass as 42 cubic feet of water. Sounds like a ratio to me. We are comparing two things. What are they? Cubic feet of silver and cubic feet of water. At 4 degrees Celsius, would 210 cubic feet of water have the same mass as 20 cubic feet of silver? So we're comparing the same two things with different numbers. This is what it looks like when you set it up mathematically. You show the first comparison, which is 4 cubic feet of silver to 42 cubic feet of water. And then you show the other comparison of 20 cubic feet of silver to 210 cubic feet of water. You have to make sure that whatever you put on top stays on top. So in the first ratio, if I put silver on top, then I need to put silver as my numerator for the second ratio. If I put water as the denominator, 42, then I need to put water as the denominator in the other one, which is 210. 4 to 42, the greatest common factor is 2, so I'm going to divide that. 20 to 210, the greatest common factor is 10, so I divide that. 2 to 21 equals 2 to 21. Yes or no? Yes. Since they equal, 210 cubic feet of water would have the same mass at 4 degrees Celsius as 20 cubic feet of silver. So, here's another example, same idea. All I did was change the numbers. Let's see if you can do this on your own. So pause the video. First thing you need to do is set it up. At 4 degrees Celsius, 2 cubic feet of silver has the same mass as 21 cubic feet of water. So 2 to 21, silver to water. At 4 degrees Celsius, would 105 cubic feet of water have the same mass as 10 cubic feet of silver? Even though 105 came first, that's water. And I put water on bottom. So we need to put water on bottom if it goes on bottom. Silver goes on top, so we keep silver on top. Divide by the greatest common factor. 2 to 21, the greatest common factor is 1. If you divide by 1, you're going to get the same ratio. So there's nothing to divide on that ratio. 10 to 105, divide by 5, and we do get 2 to 21. Since they equal, then 105 cubic feet of water would have the same mass as 4 degrees Celsius, at 4 degrees Celsius as 10 cubic feet of silver. So there is your lesson on ratio and proportions.